This K8BYP was a video on transmission line receive noise, mostly. Receiver noise due to transmission line and antenna out of tune, and addressing the myth of putting clamp-on ferrites on a transmission line to stop the noise from traveling down the outside shield of the coax. Like the other myths, completely false. Violates laws of physics. We're going to look at where the noise comes from, why the ferrites appear to reduce the noise, and why hams are plagued with noisy antennas and poor reception. Here's a TR3 open to do some more modification. Found some cool mods on this thing. And we can see a S9 plus almost 30 noise level. 40 meters, noisy right now. If you saw the video on the ASU857, I mentioned in the comments that there was noise on HF, which was caused by a melted coax connector on the 2-meter antenna. That's on the other antenna jack. Well, that's quite a mystery as to why that causes noise on HF, but there's a reason for it. I'm going to reach back here and be exceedingly careful when reaching like this on a tube rig. In this TR3, I have external control of the filaments and plate voltage on the finals, so that there's no plate voltage and no filament voltage back there, so the final circuit's turned off. I don't like the word dead. But I reach back here and do something, and watch the S meter. Now, which one of those conditions is like the complaint of, I have a really noisy vertical? This one or that one? Well, it's this one. And what I'm doing, you can probably hear it, is pulling the ring off the 259 and putting it back on. Off, the noise goes through the roof. And it's not motor noise, it's not from the lights, it's atmospheric noise. How do we explain what's happening? Well, I'll just go right to it and tell you what's happening. And then I'll show you an engineering document that supports that. What's happening is that, especially if we've had experience with putting antennas very close to the ground, they don't work well and pick up a lot of noise. On the HF and VHF, our signals are coming in at essentially line of sight. If they're coming down from the upper atmosphere, the signals are essentially coming straight down towards our antennas. So closer to the ground tends to be more noise and less signal strength. This coax that I'm on right now with the TR3 is laying on the ground probably 80 feet. With the shield disconnected at the radio, the shield is disconnected, it's open circuit. And the shield at the other end is terminated in a 50 ohm antenna, but it's open on this end. And that is roughly, very roughly, makes it a end-fed wire sticking out of the back of the rig. And the atmospheric noise just comes through to the center conductor. With the ring connected, the transmission line is terminated and is characteristic on both ends. It's tuned. It's a closed, excuse me, it's a closed entity, if you will. The shield is shielding. Where this is a problem that leads to putting ferrites on the line is when the antenna is out of tune, and opening the shield on the other end does a similar thing. An antenna out of tune with the opposite end that doesn't match the characteristic of the transmission line equals noisy antenna. What the ferrites do is cause a discontinuity in the transmission line, which is readable, and I have seen it on a TDR display on an antenna analyzer. Very bad thing to do. It puts a bump in the line, it causes reflection, it effectively desensitizes the antenna, and sure, there's less signal and noise in the receiver, but less signal also. For a physics explanation, we go to a document that you can find on Google. Search for F as in Frank 2-3- Echo Nancy _ part PART1.pdf. I think this is a engineering school document, but this schematic shows the effect of a noise source being here. Here's a noise source. Here's a conductor. Think of this as a beverage. Terminated in a load resistance, which in theory will match this. And there's mutual coupling, M, between the inductor, which is the source, and this, what we call coax transmission line, also terminated in its characteristic on each end. And here's a schematic representation of the source here and here, this inductance here, the mutual here and here, the two mutuals. One implies mutual to the shield, one implies mutual to the center conductor. And when both ends of this line are terminated, the mutual coupling from the source to the center conductor is eliminated. Well, that makes sense if it's a shield. If there's a piece of pipe around the center conductor, we can't shine a flashlight on it and illuminate the center conductor. But open up one end, make the pipe porous, the light shines through to the center conductor. That's a crude example, but it works. But what happens in the case of the improper termination on either end of the line is that the shield can no longer sink the currents which result from the mutual coupling down the line, and they are coupled, the magnetic energy is coupled through to the center conductor and is dropped across the termination. Let's say this is a receiver, and that's the antenna. It's dropped across the receiver. It's heard as air noise, so to speak. Putting a clamp on increases the inductance over the length of the clamp on, which is generally a half to an inch or so, and changes the impedance of the line, and that makes a bump, if you will, and causes reflected power. So don't do that. If it reduces the noise, you'll also find it reduces the signal. Don't do it. Tune the antenna correctly. Let me tell you, it's worth the trouble. It's not easy. It may take days. You may have to put the antenna up and take it down a dozen times, but it is worth it. This is a very good document. I really recommend that you get it off the internet. Down here is the explanation in language. The shield is not grounded, non-magnetic, and explaining what happens as the shield is grounded or not. And they go through this in detail, but a very good explanation of what's happening in the concentric line. KBYP out.